This week, we're going to learn a really cool architecture known as a Lambda Fanout, and kind of has a little to do with security. This is, I swear, the absolute last lab in our advanced cloud security problem solving series, which I also called the Epic Automation because that fit better on the title card graphic. By now, you've probably realized that I have maybe pulled a fast one on you. It seems we've spent these 9 labs learning as much about development and cloud architecture patterns as we have cloud security. The thing is, these two skills are impossible to separate if you want to work as a cloud security professional. Just as a firewall engineer needs to understand network topologies, technologies, and how to interpret packet captures, we on the cloud side need to understand our own fair share of non-security fundamentals. Today's lab is a very cool one I was excited to get up and running. If you recall, way back in the first lab of the series, we defined our objective as, if a bucket is tag sensitive in production, only allow access from within my organization. And to do this, we've spent the first 8 labs building out an event-driven architecture that would assess any buckets as their configuration was changed and enforce our desired settings on those events. The diagram looked like this. And so far, we built out basically everything except that teensy tiny little blue box in the corner that's labeled time every hour. And that thing has a whole big can of worms hiding inside of it. So today, we're going to learn all about how to scale things out with a Lambda fanout pattern. You see, in our little environment, we only have one S3 bucket to care about right now, so running a time-based scan, it's not a big deal. But imagine an organization with many thousands of buckets spread across hundreds of accounts, and I personally have that, never mind a big enterprise that has a factor probably of 10 times larger than that. Running a scan at that scale across multiple accounts from a central place would be both massively time-consuming and incredibly inefficient. We don't call AWS a hyperscale cloud provider for nothing. What we have already built is an event-driven architecture pattern that only runs as things change. No changes and nothing is running. Modify 10 buckets at once, we run 10 Lambda function invocations in parallel all at the same time. And that makes this architecture incredibly scalable and efficient and really shows off the power of on-demand cloud computing. What makes it so efficient is that we know exactly which bucket was changed based on the CloudTrail event, and our auto remediation Lambda only has to look at that one bucket and only when it changes. But this does not work for time-based scans because we don't have an event that identifies the changed bucket. We don't have anything to trigger off of, and we need to look at every single bucket in our environment to see if it meets our criteria. Now, the good news is we have other design patterns that we can use, and the one we're going to cover today is known as a Lambda fanout. We will use a series of 3 different Lambda functions to identify and then scan every bucket, and it's going to run it in parallel. Each Lambda can trigger other Lambdas in the fan pattern to run as much as parallel impossible. Okay, so here's how it works. Let's switch over to the whiteboard. Now, for this lab, I've converted that time every hour to be every 12 hours, and that's just going to help us manage our costs. And we don't really need to run this every hour. And it's going to be an event bridge rule that runs every 12 hours. It's basically like a cron job. Actually uses the cron format. You'll see that when we get in there. And I picked this instead of every hour, as I said, to go ahead and save on cost. So event bridge rules do support time-based events. Now, the first thing it's going to do is it's going to call a Lambda function known as enumerate accounts. And this starts with an environment variable, which is the starting organizational unit. Now, for our lab, the way that we've done this is we talked about only wanting to run it in production. So we input that organizational unit, so we have that starting point. That enumerate accounts then does 2 different things. So this is running inside the code, and I do show the code a little bit later. The first thing it does is it is identifying any child organizational units. Remember, organizational units can be nested inside of each other. And for every child organizational unit, it just calls itself again. And then this is going to look for more child OUs. And then that's going to call itself again. And all of these can run in parallel. So as it finds child OUs, it invokes new versions of the function, and those invoke the next versions. So now we're starting to fan out. We have our same code base, but it's calling itself over and over again. And each one of those is a brand new run. It's a brand new instance of that Lambda function. And so that's what makes this run very, very quickly. Now within there, the other thing it's doing is it is identifying the accounts in that organizational unit. And that goes from that first tier of our fan out into the next tier. So the accounts are identified, and then it calls another Lambda function, our second tier, which is enumerate the tagged buckets. What this is going to do is, and I should remind you that it's going to invocate that for every single account that it finds. And so if there's 37 accounts, it's going to run 37 versions of that Lambda function in parallel. That's what that term, I invoke it, or we call it an invocation of that Lambda function. So all 37 of these, or in my case, 3 or 5 or 7, whatever I put on there, those are all running in parallel. Now there's this second Lambda function uses a cool little feature in a capability called resource group tagging. And instead of having to scan every bucket to find our tagged buckets, we can actually directly make one API call that's going to identify all of our tagged buckets for us. This dramatically improves the efficiency, and I hate to admit it, but I never actually used this capability before, but we are going to use it for this lab. This creates a list of all the buckets tagged with a key of classification and a value of sensitive. And you can change that to whatever you want, but we're now going to get a list. And every time this runs within every single account, it's going to give us all of the buckets that are tagged with classification of sensitive. Then we iterate over that list. And for every one of those, and let me scroll down a little bit to show this. So we've identified each of the buckets. And then for every one of those, we directly call our security auto S3. And that's the third and final phase. And all of those will run in parallel. So we are directly calling that function this time. We're not actually creating an event bridge event to trigger it. If you remember, and you can see it off on the side here, we have all of our triggers that we use to trigger the security auto S3. In this case, we are just directly invoking it, and we're passing over input that simulates the CloudTrail event trigger. So we've just replicated it, and we have the two pieces that security auto S3 needs. One of those is the account ID of where it's supposed to check the bucket for the auto remediation, and then the other is the name of the bucket itself. And so that security auto S3 works exactly the same as if we were triggering it from EventBridge because of passing through this mocked up event. And this entire thing runs really fast. So in our test environments, but you won't even be able to see the logs by the time this already runs. And then in a large scale environment, it probably runs just about as fast because everything is running in parallel. Now I'm going to go back over to the whiteboard here. Let's just zoom out to give you that bigger picture overview for a second. And come on, trackpad, respond. Oh, I actually have to click on the window for it to zoom out. And so this is why we call this the fan out pattern, because we have this initial thing that triggers, and then that's going to deploy a whole bunch of these in parallel. And then those are going to deploy even more of these in parallel, and then even more of these. And so it's kind of a fan on top of a fan on top of a fan, and we have our 3 tiers. Pretty cool, eh? This architecture allows us to run a time-based scan, and it does it with a lot of parallel resources that aren't even running until the clock triggers them. Then they fan out and invoke the next layer, and that invokes the next layer, and that creates a lot of efficiency, and it works really quickly. Now, does it really scale? What else do you need to know? While this pattern scales even for massive environments, this is about the simplest implementation that we could use. And I would come up with some modifications if I was operating this at an enterprise where I had to have a little bit more resiliency. This does work. It does work very well. It works incredibly quickly because it's using all of these Lambda functions, invoking the next ones, and it just kind of fans out, works in parallel. But there are some limitations. The first is there's no error handling outside some of the basics in the code, and you're not going to see those errors unless you look in the logs themselves. One of the things that could cause this to error is that when you're working at large scale, you might hit service limits for the different AWS services, even Lambda limits if you're operating at a very large scale. AWS limits the number of simultaneous API calls that can be handled on a service. And that if you have a lot of like S3 calls or something, you could run into it and you could actually have your request denied. And we don't handle those errors or attempt to do any retries, at least until 12 hours later when our scan runs again. So that's the kind of thing that could be problematic at large scale. We also don't have any state management, and that's one of the main ways of managing those errors in those event-driven architectures. So you can know if that code actually ran successfully or if it had an error and what that error was. We're not tracking any of that. Technically, it's all in those CloudTrail or CloudWatch logs, but we're not looking at those in any kind of an active way. We are also not tracking or logging any of the changes we make outside of what you're going to find in the CloudTrail logs. And yes, it is very verbose. It will tell you that our auto remediation made those changes. But again, you're having to go into CloudTrail. You're not going to see it someplace very consumable where you can see that those changes were made. We're not even doing any notifications on it. Now, these are all manageable problems, and using tools that will tend to mix and match in our architectures like EventBridge, Dynamo Database, or Elasticsearch, Simple Queue Service, Simple Notification Service. And we'll probably get to some of those someday, but we're not going to use those for this lab today, which is just the most basic, the most fundamental Fanout architecture, and using it within a security context to do time-based assessments. And this pattern will work for other kinds of time-based assessments if you want, although you might not always have, if you're not looking for tags, you might have to kind of iterate some stuff a little bit more manually. Or just go ahead and buy a commercial tool. This architecture is really similar to how the commercial product I built with other people called Fireman Cloud Defense operates, because that's fully serverless. And most are going to be in a multi-cloud, large enterprise environment. In those cases, you should probably consider buying versus building. I don't want to lead you down the wrong direction, and you probably already have something where you work. But it is important to understand this architecture because there's probably things you're going to want to build yourself as security professionals, even outside of the tools you have. And it's just kind of cool to know how all this stuff works. All right, let's jump into the lab. This would be a lot to build out completely by hand. So I packaged it all up into a CloudFormation template. There's still a few steps to get it up and running, and I'm including all of the code over on the blog so that you can review each piece. We do have a few steps we have to put in place to make this work other than just the CloudFormation template. The first is we're going to need to delegate administration for AWS organizations to our security operations account so it can read the accounts and the organizational units. That Lambda function needs to be able to read the OUs and the accounts, and security operations has no permissions for AWS organizations because that runs out of the management account. Now, as you'll see, we'll use a restrictive resource policy for only the minimal API calls that are required. We have to deploy the main template after that, which loads the 2 new Lambda functions from public S3 bucket. So instead of copying and pasting, I'm hosting these in one of my environments. We also need to create 2 new roles. So we have those Lambda execution roles, and we need to create that EventBridge rule that runs every 12 hours. And you can go ahead and look at that template. I'm not going to go through all the details of it, but you can review that to see how it works. And then we finish up by updating our security auto remediation role by updating the template in our CloudFormation stack sets. This is like the second or third time I think that we've done that. Now this step has to go last because it's allowing our new Lambda functions and those roles to use our existing security auto remediation role. Now remember, that role is the one that exists in all of our target accounts. And so it has to have permissions to use those because we locked that down in our previous lab when we learned how to secure role chaining across both ends. We also need to add, and this is part of that same step when we do that updated role, we're adding permission to use the the API call tag::get resources so we can find our tag buckets. Now, since all this deploys at once, I'm going to very quickly just show you the code, starting with the enumerate Lambda function and then enumerate accounts function, Lambda function, and then the enumerate tagged buckets. So up here, I have enumerate accounts. This is actually my integrated development environment where I create all my templates and such. So you can see a little bit more than normal here. These are all the things that are packaged up into the zip file that we load into your account. And here's the actual Lambda function itself. It's pretty short. So you can see that what it does is it gets all the accounts from the parent OU. And so it's got some paging, and then it gets all the organizational units. And then here's the fan out. For every organizational, there's two fan outs here. For every tagged bucket, it's going to go ahead and launch the Lambda function to find, for every account, it's going to launch the next Lambda function to find the tagged buckets. And then it will also invoke itself again to go ahead, and then a new version of it is going to go ahead and run so that it'll actually iterate down into the next level of the organizational units. And you can see that API call here. So that's going to launch a new version of itself. So it's kind of a cool part of the fan out. And then this is and again, if there's multiple OUs, it's just going to keep launching more functions to drill down in the architecture. And then here's the invoke, and it is going to go the enumerate tagged buckets. Now that enumerate tagged buckets code, that's down here. And this one is also, it's not very long. You can review it all in the blog post. But the key one in here is that it has the API call, tagging client. So it's going to do the tagging, and then it runs through and it makes the API call to get the key and the value of sensitive. Let me pause for a second, actually pull the API call. And so yes, that's pulling all of the tagged buckets. And then for every one of those resources, it's actually mocking up our payload. That's our fake little event. And then it calls security auto S3, and you go look at last week's lab to see that code again. Okay, so that's just a quick overview of what this is doing, but you can see the three tiers. Let's find all of the accounts. Then for every account, and that includes finding all the accounts nested in OUs, for every one of those, we're going to launch the find the buckets that are tagged. And for every one of those, we're going to launch another security auto S3, which does what we've done before, which is checking all the settings to make sure that that's locked down. So really efficient. It's a very cool way of doing this, and it works just insanely fast. Okay, now we're going to switch over, log in, and we're going to actually start the implementation. From your sign-in portal, the first thing we need to do is get our production OU ID, and we are also going to need to go ahead and set up our delegated administration. So go into our main Cloud.SL account, administrator access, and then we're going to go to organizations. And I've got it right on my pick list, or it's up in the corner up there again, AWS organizations. And this lists everything right out. Remember, we're only wanting to run this in our production OU, and that's going to be that environment variable that we feed in. Now, we don't have any nested organizational units. We just have the one account there, but having nested OUs is actually something that happens very commonly. You might have one for accounting or your web servers, client, customer database, whatever. So let me go ahead, and I'm copying that onto my clipboard. You might want to paste that someplace else. My clipboard can keep multiple things at once. But now we need to go into delegate administration. And before we go in to do the delegate administration, we do need to know the account ID of the account we're going to delegate to. And that is security and our security operations. So I'm just going to go ahead and copy that onto my clipboard as well. Now go to policies. Oops, sorry, not policies. Go to settings. Within settings, delegate administrator for AWS organizations. So we don't have anything delegated, so let's go ahead and click delegate. And it's a policy that gets put into place here. Now, the policy, I'm not going to have you click on the list here. There's actually a little bit of a semi-bug in how this part of the console works. So it works out a lot better because it doesn't let you fill in the principles unless you type it in by hand. So I have stuff preset. So if you go over to the blog post, and let me go grab it from the blog post, and you'll see a place to insert your account ID. So let me go grab that. Okay, so I've got that template from the blog post. I'm going to paste it in, and you'll see there you just have to swap in your account ID, and that is going to be for your security operations account. So let me go get it off my clipboard. And I pasted that one in. So that's the account ID for my security operations account. And that's the little tricky part because principal, there's no place to enter the principal here. So you just have to know what that string looks like. Create policy. Now that's all you need. So this is actually delegated and it all works. Remember in a bunch of our earlier labs, there's all sorts of stuff to set up for delegate administration for organizations. This is how you do it. I really wish there would be some consolidated and consistent way, but whatever. That's why I don't get paid the big bucks by AWS. Now, the next thing we're going to need to do is that I believe is everything in this account. So let's close out. And we're going to go into our security operations account with either security full admin or administrator access. Once we're in here, we're going to go into CloudFormation. So on me, it's on the list, or just type it up there. And we're going to have to deploy 2 stacks, one locally and then one using stack sets. So the first one we're going to do just straight here from CloudFormation, and we're going to go create stack, choose an existing template, Amazon S3, just like we've been doing everywhere else. And look at that. I even named it after the lab number. The numbers aren't totally accurate because I didn't count some of the other challenges and things, but close enough. So the stack name we want is, let's just call it S3 S3 scanner. I made that up on the spot. You couldn't tell at all. Now we need our production OU. So remember I told you to copy that onto your clipboard, paste it somewhere. Let me grab mine. And that is my OU. If you can figure out a way to hack my account with that, good luck. Enjoy. So now I've got my name, S3 scanner, OU, and let's click next. And we're going to just scroll down here. This does create a couple IAM roles. So we have to click our magic blue checkbox and click next. Scroll down and click submit. That's it. So we're just going to let this thing go ahead and deploy. If you want, you could actually go ahead and also look at the template itself. And you can see that it creates a role with the policy that allows it access to do all the Lambda thingies. And it gives us access to invoke another Lambda function. So we're pretty tight on a lot of our security controls here. Then the enumerate accounts the Lambda function itself. Yes, you are loading arbitrary code out of my account. So I could hack and take over all of your accounts. Probably couldn't do much because that role is relatively limited, but you do want to be careful. And that's why we do all this in a test environment. If you run this someplace real, you are on your own. Then we create for our second Lambda function, the other role to enumerate the tagged buckets. And you notice the only thing it has access to is to assume role into another account and to run that security auto S3 Lambdas no matter what account that it's in. And those are the 2 things. It needs this access to go ahead and do the actual bucket enumeration. It needs this to run our centralized a Lambda function that is in this account. Then we create that Lambda function. Same thing, coming out of my account. So yay, I own all of you. Then it's scheduling the rule to run every 12 hours. So there's some text, and this is basically similar to a cron job format. And then we do some permission changes so that it can actually run the Lambda function, and then it's just output some stuff. So pretty straightforward, pretty simple template. And let's go back over to the info here, and my create is complete, and I managed to babble away the whole time. So this is now all up and running in our environment. And if I go into Lambda, you can see that I'm going to have these 2 new functions here. Our old one, and these are the 3 tiers for our Fanout. Look at that. It's nice, even in order. I did not plan on writing them in alphabetical order, but I'm going to roll with it. Okay, going back over to CloudFormation. Right now, things would break because we don't have the permissions that we need to go into any of our target accounts. It can only run things locally. So we're going to go to our stack sets, our service managed stack set, and our auto remediation role that we've been working with the past couple of weeks. From here, you want to make sure you copy out that organizational unit ID. You are going to need that as we update the stack. Then go to Actions, Edit Stack Set Details. And we are going to replace the current template with the one that is in the blog post. Let me go grab it. Paste that one in, and you'll notice it's labeled differently. It's the role template. Click Next. All of this stays the same. Click Next. Little magic blue box that we're creating IAM permissions. Click Next. Now we have to enter in that OU ID. And this is the OU, if you do not remember, for all of our workload accounts where we have that role deployed. So it's deployed more broadly than where we are actually going to run our auto remediation on. Then we're going to go ahead and add all regions. And we only need one because honestly, there is like one account, two accounts in there. It goes pretty quickly. And then submit. So now that's up and running. What I'm going to do now is I'm going to show you briefly how to test and how to look in your CloudWatch logs if you want to see, make sure that all of this is working. But as I mentioned, we deployed the new Lambda functions, we created that event bridge rule, and we created the permissions to wire our entire Fanout architecture together. It didn't take very long. That role update is out there. Now I am going to show you how to test this, and let's go to Lambda. It will run every 12 hours as well, and the first run will probably happen relatively quickly. Although if you see errors, it could be because it ran before that role deployed. So everything starts, as I mentioned, with the top level enumerate accounts. You only need to run that once, and then it will keep calling itself over and over again as needed. Although in our case, we don't have any nested organizational units, so it won't matter. Just go to test. And we don't need a test event or anything because it's triggered by a cron drop. It's triggered by a time-based trigger. So just click test. Now it's executing the function, and that's it. So it went ahead and ran, and it found, invoked find sensitive buckets for the only account that's in there. You'll notice also if I go to the configuration that we have the environment variables, and this is that production organizational unit. So it was only looking in that production OU. That OU only has that one account. Then if I go to see how the rest of this ran, I go into CloudWatch. So we'll go to CloudWatch, and we'll go to CloudWatch. Didn't have the shortcut I was expecting. We go to log groups. And if you remember, Security Auto S3 is kind of the end tail of this. That's the one that's going to run to do all of the assessments. So I'm going to click on that one. I'm skipping the middle step. I'm clicking to the end. You can tell when I'm recording this. I'm double checking my clock. Yep, that's actually the exact time shown on my clock. So it already ran, and you already see results. So that's pretty cool. We were able to trigger it manually. You can do that anytime you want. Otherwise, this will now start running every 12 hours. I love this Fanout architecture. And even though we're only using it for one account, this would really easily scale to hundreds or thousands of accounts using the same architecture. Just remember those constraints if you're in a larger enterprise environment. Thanks, and have a great week. And hey, by the way, this is lab number 9. It is the end of our epic automation, the advanced cloud security problem solving. So think about it. It took us 9 labs to plug in the hole for that, because of we couldn't use the resource control policy on tags because you can't use tags in a resource control policy. It was a lot, but I think it led us down a cool path, and I think we got a lot of cool lessons out of it. Thanks for sticking with me.